Good morning or good afternoon in this exceptional event here in Hamburg under this a bit strange circumstances. My name is Klaus Müller. I'm with Aerodynamic Advisory. We are a management boutique consultancy headquartered in US. We are having an arm also in Europe, but this is the minimum advertisement. Whenever you have any questions regarding consulting, management consulting, if you have any problem, call us. Excuse me. Yeah, I have the honor to have an excellent panel here on the stage, and the name of the panel is Charting the Course of the Net Zero Aviation, and I just wonder how big this chart should be, because this is definitely a huge pattern, a huge board we have to drill. And I think I will ask my questions more towards this short and mid-term activities. We learned over the morning and yesterday a lot of these future fantastic ideas we have. But on the other hand, there is still a time to go. So I am happy to introduce Frank Haselbach from Airbus. We have Gaël Méheust, where is he? Here, from CFMI. Then we have Colin from Collins. I think you heard this joke. How often?
Many times.
Many times. And we have Olivier Ribet from Dassault. We have Pierre Hamelin from Liquide. So I think we have a bright panel around. I also want to drive your attention on Slido. Please shoot questions to us, as many as you can. And we also have a poll in place, which we are intending to go through your results in the aftermath of this panel. So starting this a quick introduction, a quick setup. Where is it? Here we go. I think we all know that there is no silver bullet. Even if we all would cross our fingers, there is no silver bullet, and the industry has to learn to cope with multiple activities to decarbonize the industry. I think this is a very key message, and this is maybe new for all of us. And we have these different tiles, and I have to admit that I stole the idea of tiles from Airbus, so sorry for that. But we have at least these huge areas where we have to develop. There's this market-based measures. We have a lot of activities in the operations and ATM, and of course, technology is a key subject. I'm pretty sure we will spend some time also on the technology development. And in the far end of the decarbonization, there is maybe hydrogen solutions, and in between we have the SAF solutions. But there are also some activities which are down on the ground, infrastructure, manufacturing processes, which is also helping to decarbonize or to defossilize the industry. So, having that said, maybe I'm starting with Frank on the opposite end of the stage. What are the activities you are doing, and or you as a person and you as Airbus to get towards this topic?
Okay, very much. Thank you very much, Klaus. So, good afternoon, everybody. Frank Haselbach from Airbus Propulsion Engineering. So fundamentally, I don't think that this is actually just a short and medium-term focus. There is also, if you look at it, the long-term focus, and all the stuff we're talking about is about the next 10,000 days. Because 10,000 days, less than 10,000 days away, is 2050. So it's pretty close. And consequently, we in Airbus have looked at the challenge we have. And if you look at the aviation industry today, 3% of the world's sort of climate impact via CO2. That's about 1 billion tons of CO2 per year, based on 350 million tons of fuel burned. And clearly, the first thing we need to do is to make sure that the operation we're doing today in the world, with the 25,000 civil aircraft flying, is actually using less fuel for the same task. And that is done by getting new aircraft into the market, and that's what we're busily doing. And of course, that's quite nice because it's also our business. So that's number one, that's the first step. The second step we have is to say, okay, so if we look at the next generation of aircraft, what are the key technologies which will drive these aircraft to be even more fuel efficient? Normally, every generation of aircraft is roughly 20% more fuel efficient than the older one. And you normally get this via propulsion and size, materials, and wings. Those are the things which make aircraft better, and that's exactly the stuff we're working on. And then, of course, to cut through the fossil fuel sort of situation, we have to go and close the carbon loop, which means we have to go to sustainable aviation fuels, and we are strongly supporting that in biofeedstock, but also in power to liquid, which then, of course, means that you have to find ways of generating hydrogen with clean energy, carbon capture, and then Fischer drops some synthetic fuels, and then make sure that you're actually making this in a form of, let's say, drop-in fuels in the first place, because you have a lot of old fleet flying. And finally, we are very strongly sort of championing the agenda of hydrogen in aviation, as you know, which of course has propulsion in its center as well. How do we actually convert the hydrogen energy carrier into sort of propulsive thrust for the aircraft? Having in mind we're using less energy to produce a hydrogen than sustainable aviation fuel. And that's why we think that whole mixture together gives a package which is the right thing for the next sort of 9,950 days.
So it's multiple target. Yeah. Olivier, I wonder what you could share with your targets and activities you're doing at Dassault.
So thanks again for the invitation. It's always a pleasure to be at the Aviation Forum. Hello, Jürgen. It's clear that this is an industry that is core to Dassault Systèmes history, R&D effort, investments and development. After many years focusing really on CAD, on simulation, on PLM, it became very obvious 10 years ago for us that the next two biggest transitions will be on the material science, something pretty fundamental happening in crystalline structure, metallic alloys, fuels, energy, etc., etc. And that it will require a profound transformation of the way engineering, manufacturing, and operation will happen. So in the previous panel, we were talking about a twin or a shadow, whatever. It became very, very important for us to make sure that this representation of what an existing product, an existing plane, an existing mobility system is today will need to continue to be improved continuously while waiting for the next generation of architecture and energy to come. So we're in a very, very particular phase right now where we don't start with a blank page. We continue to have huge legacy of tools, method, techniques, people, skills that need to keep the plane flying while having the same quantity or capacities and skills in more constrained resources to prepare next gen. So this transition requires a handover of process, method, and tools from past, present to future that is quite difficult. The complexity doesn't come just from a topic of engineering. All of us in this room know that the political regulation, the political context, the economical situation, the technology that come creates both tremendous opportunities, but also a level of complexity that none of us had to deal with in the past. So to answer your question precisely, we think that only a systemic approach, a systemic modeling of all the constituencies, engineering, manufacturing, political, regulatory, constraint, skills, is an answer. And we have been working really, really closely and really hard with many of you in this room, and we'll continue to do so.
I'm sure that I'm coming back to this digital twin idea, but I'm very sure that this is in the dreams of many companies. Nevertheless, Gaël, I wonder, because you are in a situation that you are growing, you're blasting engines out of your shop in large numbers, and at least there's the next on the horizon already. So I wonder what your actual activities are to prepare for this situation.
Yes, Klaus, absolutely, and thank you for saying that. We are quite successful today already, but this industry has set itself the goal of being net zero carbon in 2050, and Frank mentioned it, propulsion is going to be a big part of it. So at CFM, we strongly believe that we need a step change. We are not going to achieve it with just an increment in terms of technology. Of course, there are the fuel like SAF and maybe hydrogen. Our engines are already working with, demonstrated their ability to work with SAF. So I'm not going to really talk about it. I'm just going to talk about the technology part of it. When we look at the last decades, the engines today are 40% better in fuel efficiency and therefore in CO2 emissions than the engines they replaced in the early 80s. So looking forward, we think the step change needs to be significant, and we have set ourselves at CFM the goal of achieving a 20% improvement in fuel efficiency and therefore in CO2 emissions, because this is 1-to-1 ratio there. How are we going to do that? So we made a big announcement in 2021. We launched what we call the RISE program. RISE is a technology acquisition and maturation program. Stands for Revolutionary Innovation for Sustainable Engines. That's the acronym. But the goal is to bring to the market an engine that will be 20% better in performance and in CO2 emission at the horizon of the middle of next decade. So how are we going to do that? Well, simply we are going to completely change the way an engine looks. You know, we are used today to see engines where the fan is encapsulated into a nacelle, like cowling. We want to remove that nacelle, remove those cowlings, and allow the fan to grow significantly into an architecture that we call the open fan. Open fan will have a big fan of 4 meters in diameter with nothing around. So it's going to be visually very different as compared to the engines we are used to see today. And if you want to see it, you just go on CFM website. You'll have a representation of that open fan engine. We are used to compare the perceived efficiency of engines with a ratio. I'm not going to be technical. We call it the bypass ratio. So in late 70s, early 80s, this ratio was close to 1. Then came the CFM56. This ratio was 6. Then came the LEAP. The ratio is 12. When we talk about an open fan, like the one I've been mentioning, we're now talking about the bypass ratio above 50, bigger than 50. A true step change in architecture. So that's for the fan, but the technology is going also reside in the core of the engine. And we are heavily investing to design a core that will be much smaller to what we are used to see today on engines, much smaller. To give you a kind of a comparison, the open fan is about like an engine with the fan of a G90 with the core of a business jet. That's about the ratio that we're talking about. And that core will yield very high pressure, very high temperatures. Temperature is good. Temperature is good for performance as long as you have the material to sustain it. Mm-hmm. So we're working on new material, CMCs obviously, to sustain those high temperatures. And the combination of this big fan, step change in propulsing efficiency, and this very compact core that will yield very high pressure, high temperature, will take us to the 20% plus hybrid electric and other features on which we are working. So this is not 2050, and I agree with you, Frank, sounds kind of far away. For us, this open fan concept that we plan to, by the way, ground test in the middle of this decade, and probably 26, 27, and then flight test, because we have an agreement with Airbus. Airbus has been so interested that we signed an agreement by which this open fan demonstrator will be tested on the flying test bed of an A380. We are really working on it. We have more than 1,000 engineers. So today, the open fan and rise is our present. This is not the future at CFM. We're cutting metal already to make the demonstration. So SAF, other, yes, but for us, our responsibility is to bring a step change in the engine design so that we can achieve at least 20% of improvement.
Thank you. I have plenty of more questions.
Good.
Pierre, maybe you share your view. We are coming now from the equipment and the systems behind it, but from your view, I think what are your next or your targets, and what are your initiatives you started?
Thank you. You know, if I look at the roadmap of aviation, which was shared by IATA, ICAO, ACAC, over 50% of the decarbonation journey will be based on alternative fuels. So once we have said that, we in Air Liquide, we have 4 axes of contribution to the advent of the hydrogen aviation. Because we are, many people talk about it, but we are part of the very few to have operated it since 20 years. I'm talking about liquid hydrogen. The first axis basically is what we call onboard. So we work with OEMs. We support with our technology knowledge so that they overcome their techno locks with regard to their techno bricks which they need. And we try to be as concrete as possible. The best example is for those who have followed in September. There was the very first flight of a fuel cell with a pilot and the liquid hydrogen tank in Slovenia, September 23. It was our tank, designed, tested, fueled by us. So this is for what we call onboard, and just to be clear, we have no interest, we will never be a supplier of aviation, we just transfer technology. The second part...
I expected that you'll become number 3 aircraft manufacturer.
This is not our direction. Our direction, you know, we are a gas and energy supplier. We are not an industrial company. We know it, and we know what is our place in the value chain. The second area is what we call ground assets in our language. Again, we have collaboration with OEMs, as an example, very concrete, to define the refueling processes for the airplane tank from the refueling assets on the ground. So we are working on the refueling processes and later on prototyping. The third contribution we have is we work on the infrastructure. This is probably more expected from us. So we have created a unique company called Hydrogen Airport. With the group ADP, the only purpose with this joint venture, which is a pure engineering company, is to help airports to project themselves and to find the answer on what do I have to do, when do I have to do, and how much would it cost when liquid hydrogen will arrive in my airport. And the last is basically we contribute to the regulatory framework, be it on safety, be it on the operating model. So these are the 4 axes of contribution of Air Liquide to the advent of the hydrogen aviation.
So it's a clear focus that you are providing all the surrounding infrastructure systems which are necessary to transfer into a new energy system.
This is basically, I mean, actually the new fuels, be it e-fuel or be it hydrogen, not many people know, but we are agnostic. It means, you know, to generate 1 megawatt with e-fuel, you need more hydrogen than if you use it directly. So for us, they're all equal. So what we try to do is put all our knowledge and infrastructure ready for the advent of the hydrogen aviation. Of course, the only thing which is out of our battery limit is the production of the renewable energy. This is not something in which we intervene.
So we have the engine, we have the ground, we have the systems. Colin, what do you contribute to make us net zero?
Well, thank you, Klaus, for giving me the stage here. I think your last slide was really, really important. There is no silver bullet. Right? This, and just listening to my colleagues here, this is going to be a team sport. And as a major system supplier, so Colin's Aerospace, just to remind the audience, is comprised of 4 iconic historic names: Hamilton Sundstrand, Goodrich, BE Aerospace, and Rockwell Collins. And as such, we've got the very unique opportunity to look across the boundaries of those 4 great companies and put this together in a holistic way to contribute to everything we're talking about. So we think about it in 3 buckets. Of course, there's propulsion. Right? So we've talked a lot about propulsion, so that's 2 components of propulsion. It's what you put in the tank So I get the agnostic nature of that, right? The various ways we're going to go address that. And then what do you combine with the regular propulsion? So is there a hybrid environment in our future? So we talk a lot about propulsion given our electrical systems and engine control systems. Then we also know bucket 2 would be the connected aircraft. So we know now that our modern airplanes have got multitudes more data. They're efficiently communicated with. So how can we use that with assets that we have, such as FlightAware? You saw us historically by ARINC, we acquired FlightAware. So we have tremendous knowledge of what the airplanes are doing in the airspace. So the efficiency of moving those from A to B in a very cost-effective and fuel-efficient manner is the second element of where we focused. And then the third area I would say is in the structures environment. You know, the structures world is advancing. We've got different capabilities. We've now very focused on thermoplastics. So think about what that's going to do for our airplanes around weight, size, cost. You know, so if you take weight out of an airplane, obviously equates to fuel burn. And so the more focus we can bring around thermoplastics, which by the way are also recyclable, that's a great sustainability story. So, and then what do we do with the structures? Is there an integration story that goes with that? So the actual material, but the holistic integration. And if we do that with a foundation of collaborating with airframers, collaborating with our partners, and then obviously governments around the world, we'll be able to accelerate that journey and do it not in a silver bullet manner, but piecemeal. So you talked about short, medium terms. There are things we can do now.
Yeah.
You know, I don't know who in the room can actually predict when we're flying commercially with hydrogen in tanks. That's a bit more longer term story. But there are pieces that we can do to take 5% out here, 5% out there. And so that's where we like to focus.
There is, at the end of the day, there's one generation of aircraft in between.
Yes.
And this has to be at least minimum 20% better in fuel burn, and all the technology we can gather, we should bring into this. This brings me at least to my next topic. The question I have is maybe under the keyword factory of the future, because we are still in a phase of delivering a lot. Airbus is ramping up the production, and all the suppliers are ramping up. But what are you doing at least to improve your production in terms of improving also the CO2 footprint in your company at all? So not only at the products, also at the production. Maybe I'm starting now with you.
Well, so the scope 1 and scope 2, which you're referring to, in our view, is much more straightforward than the scope 3. So when we go and create energy neutrality through solar and all other different means, so each one of our factories has a roadmap to that future state. So, you know, we have full control over scope 1, scope 2. There's really limited excuses for not getting that accomplished in a relative medium term. It's the scope 3. So, you know, how are the things you put in the market, how are they used? How do you facilitate their use? So I think, we're investing in green energy everywhere we can do it. Several of our factories are already completely neutral as we speak. So, but that's a journey of trade-off of investment and timing.
Pierre, is it also in yours?
I think for us is a fundamental different ballgame because firstly, and this is probably the least visible for the audience, we are the leader in terms of carbon capture technology, and this is what we sell to those who produce the CO2 to capture it and then to sequestrate it, be it metal business, be it glass business, or simply hydrogen production. So this is really our access number 1 for decarbonation of existing production, because we should keep in mind that there is, as you mentioned, no silver bullets. Today in the world, there's 90 million tons of hydrogen produced per day from fossil fuel. You have 2 options: either dream of replacing everything by renewable, maybe not for today, neither for tomorrow, or start to cleaning it, and the solution is called carbon capture. What you do with the CO2, then it's a different discussion. Either you sequestrate it or you transform it into e-fuel. Our second contribution, of course, is our investments in the production of green hydrogen, which we do. And the last one, which is the least visible, is to understand the future, we have to look back to the past. Look at what happened with the GNL. GNL was something which was the gas transported by pipe, and this was what it was. The game fundamentally changed from the day we learned how to liquefy it and how to transport it. Then it became a worldwide traded commodity. And I think same would happen with liquid hydrogen or alternatively with ammonia. What it means that it will open for the first time ever the global export and trading of renewable energy. And then the ball game will become different between countries who produce it at $100, $120 per megawatt versus those at 25. And this is also our third and last contribution to enable the global export and import of renewable energy, which I think is really something which will happen within the next decade.
At the end, we are speaking about we all need the power, and all other industry needs the power. And the question is, where do we get it? Green. Maybe, Gaël, what is your factory of the future? I remember a few years ago, before COVID, there were these nice videos showing very aggressive new factories for the future. Is it still ongoing?
So I have an easy answer for you, Klaus, because as CFM, I don't produce the engines. My parents are producing the engines. My parent companies, Safran and GE. So both of them are absolutely heavily involved in reducing the carbon footprint of their productions. For us, the factory of the future is really a factory that will enable the ramp up of our production. Some of you have visited the assembly line that we have in the south of Paris, in Villaroche. It's a moving line, so it's not quite what exists in the automobile industry, but there is a little bit of it, and we have 3 lines, and it's absolutely stunning the effort that is being done in cutting short the processes, make sure that all the supply is available for the people to assemble on time. I mean, it reduces the assembly time of an engine now to a few days, actually, plus automated controls and everything. So, but again, when it comes to talking in detail of the decarbonization of the factories, Safran and GE should be the one talking about it.
Pierre.
So I might be able to talk a little bit about Safran aircraft engine.
Good, yeah. that's good because
it's clear that the work that we have been doing together on not looking at a manufacturing plant as a physical building with a process, but as something that is part of a bigger systems of production, where you are dealing with material, you are dealing with tooling, you are dealing with processes, and you are dealing with skills. And if you are out of balance in one of these dimensions, you are forced to slow down and rewind. And as Gaël was saying, you never want to go left, you always want to go right in the line. So what we have been working, and I have to commend the work that Safran has been doing in this space, is partnering closely on modeling as a system all of that, including in the training and skilling of people before they go on the shop floor, to make sure that every single operation is efficient on cost, on time, on energy, on precision, to make sure that you don't have to waste anything. It's not just time, but it's also energy and tooling and molding and etc. etc. You prepare people, then you assist them. The virtual twin helps to assist and conduct step-by-step guidance on what needs to be done. So the precision creates not only a quality in the production process, but also in context assistance that is provided to the people who are working on this transformation. And last but not least, you need to inspect that the quality is there, so that there is no deviance between the virtual mock-up that you built initially, the process, and what is coming out of the chain. So the distance between the virtual and the real is getting closer and closer to 0 now on material and process and tooling. Now the question is, are we going to do the same on new energy, when to consume, what to consume, how to balance the energy? We do that with a company in Sweden, for example, called H2 Green Steel, who is inventing a new manufacturing process of the future to produce their own hydrogen that they use in steel mill, that is going to be used then by the aerospace industry to reduce their carbon footprint. So it's really an ecosystemic view of thinking holistically. I think that both of you said that before. But the question is, are you going to do that with Zoom and PowerPoint? We don't think so. It requires to have a referential of a systemic way of thinking about a product, the energy, the skilling, the tooling, the process, and have an end-to-end view of that and pilot it with a what-if scenario.
Yeah.
I think you...
Okay, last but not least, so fundamentally, clearly at Airbus, we very clearly went for the SBTi accreditation. We opened our books and showed what we're doing on the operational side in our own production, how we're influencing the operation of our products, and how we're focusing on actually making them more fuel efficient, even if they're out there. For instance, we have our sort of in the group NAVBLUE, which is helping to optimize flight routes and so on in order to get fundamentally the benefit of having less sort of fuel consumption, consequently less CO2. We also very strongly work with our supply chain because not everything in Airbus is produced by ourselves. So we have a huge supply chain. Of course, we're influencing this. We're helping them to actually get more efficient. Our own footprint in terms of factories is super efficient. And we are nowadays have changed all our sort of internal testing and delivery flights and also our sort of beluga transport within the different sites is working on SAF and SAF plans. So we're doing a lot, and we clearly actually have a strong focus on this. And if you look at the total recycle, so the total life cycle of the product, and if you look at the next generation of aircraft, where we're talking about, of course, internally, what are the technologies we need, one of the top-level aircraft requirements will be recyclability of the whole thing, and not just elements of it.
Yeah, these are interesting statements. So there is, my opinion, there's a lot of movement, but at the end of the day, somebody needs to pay for it, and this drives me directly to the question from the audience. Thank you. This is the first question I would like to shoot to the panelists. In order to push towards the net zero goal, the fleet structure needs to radically change once zero e-propulsion is available. Are customers and ultimately customers, passengers, willing to pay for replying fleets or changing fleets and also for higher ticket prices? We had this discussion briefly before we started, so maybe we start in the middle with Gaël this time.
Well, you know, it's a good question. As far as Safran and GE are concerned, my parent companies who are investing in engineering for this RISE program, most of the money that we're investing comes from our own, pocket. You know, we are really spending every year a gigantic amount of money in research and technology, but it's not new. That's what we've been doing for the last 40 years. You know, every time we prepare the future with massive investments. So as far as the engine is concerned itself, I don't see why the engine of the future will be tremendously different in terms of economics as the engine of today. I think if we come up in the future with solutions which are way more expensive, or whether it's acquisition cost or maintenance cost, then we will probably meet, a resistance. This is not the goal. Of course, an engine is a very sophisticated thing, and when it comes to maintenance costs, sometimes at entry into service, it's a certain level, and with time, you're able to achieve significant reductions. It took us 25 years, for instance, on the CFM56, to bring the maintenance cost where it is today. On the LEAP, we've cut short so much, because after about 9 years after entering into service, we are already there where the CFM56 is in terms of reliability of the engine. So a lot of effort is also spent in our engineering process when we design the engine of the future to factor in those elements and make sure that we come to the market with a solution that is acceptable on a financial standpoint to the flying public.
Yeah, so sorry to be a bit cynical here, but though there's no additional cost pressure for the airlines to expect from the engines.
I mean,
But don't get me wrong. I think maybe Pierre, you have also a strong opinion on that. Gaël, sorry.
No, I think the cost is what I call the elephant in the room. So this is something which we have to address very openly. If we look at today rates of kerosene, which are below $1,000 per ton, the HEFA produced SAF will be at how much? 3,000, and the e-fuel more than double. Yesterday there was Hedwig who was mentioning that 1% SAF use is 1% extra on the price ticket. So my belief is we will have to walk on two legs. Earlier this year I was in Amsterdam at the board of directors of one OEM company, one airplane manufacturer, where they did a survey among 45 airlines to mention and to study price elasticity. Price elasticity is how much people are ready to pay more for a green flight. And actually it was mind-boggling to see the difference per region. It was 0 in US, and in some countries in Europe it went out of 50%. So leg number one is I believe there will be impact on the price of the tickets. But leg number two as well is we have seen that we have the price on the OPEX of the energy itself, the assets, the airline, the airplane, and basically the infrastructure, which in some regions of the world are heavily helped today to absorb the cost and the difference of cost. So I believe the impact on the price of an air ticket in 10 years from now will be a mix of both.
Mm-hmm. Pierre, sorry, Olivier.
No, I think that the conversation we had right before was also not only a question of additional cost, but also potentially missed revenue opportunity. We have more and more new generation people who are not preferring the plane as a way of transporting themselves because of our collective incapacity to explain that it was a safer, cheaper, greener, more sustainable transportation system. So there is still some doubt there, depending on the countries, the perception. So I think that we see in certain generation, in certain countries, a willingness to re-engage more actively in the transport by planes, if collectively we can demonstrate in a non-biased manner with solid scientific evidence and clear economical model that this is worth it, not only economically, but also from a sustainability standpoint. So I think that's one point. The other one is, I think that some leaders, Guillaume Faury, not to mention it, a few days ago said, you know, the transition that we are talking about is something that we as an industrial company are going to drive.
Yeah.
Economically speaking, we know that we have our fair share of the effort to do by ourselves, but it cannot be only us. So at some point, it also raises a question of how the cost, perhaps not of the engine or the plane, but the infrastructure is going to be partially, totally, or not at all absorbed by the economies and the government. The same way we have been doing that on some domains in the past, on infrastructure for telecom, we did it. On electrification of electric vehicles, we are kind of middle of it. The question is, are we going to do it also on something that is transporting a lot of people and creating probably the ultimate level of freedom in a human being? So, is it worth it?
Maybe I'm adding.
I think so, yes, absolutely.
Maybe I'm adding to this question, Frank. Do you see any whatever regional differences in this future flying behavior? Is this changing? Because we here in Central Europe, I have always the feeling that people getting a bit reluctant towards flying, though they see it maybe not as positive anymore. US, I would say there is no change at all. Revenge travel is filling airports. And so what is your opinion on that?
Well, I think the data around us doesn't suggest that it's actually people getting very tired of flying. It's definitely, if you look at the statistics, we're very much back to the 2019 levels of air transportation in most regions. Clearly, if we look at all the complexity of the topic we're dealing with, we know the fuel of tomorrow will be more expensive because it will need more energy than the fuel of today to be produced. That is a fact.
Will be more
So
expensive.
we're effectively in a different oil crisis of the early 1970s because we're looking at a huge increase in fuel price and fuel efficiency and good use of that sort of fuel efficiency in terms of the product is quite important, but also then showing the alternatives. If you, for instance, look at countries like India or China or other areas where you say, well, maybe there's no real sensitivity for the sustainable flying, you also have to look at the alternatives. Do you build, thousands of miles of road and concrete with a sustainability impact? Do you build tracks for trains when they're not there? Or do you just use commuting from smaller regional airports with a sustainable aircraft, the ones which we're trying to get into the market in 15 years from now? So those are the questions we have to tackle in that aspect. And definitely, there's not only the tiredness of flying, there's also a real alternative for a lower carbon footprint future with more flying in that context.
But it needs at the end a change in the mobility behavior at all. Yeah?
Absolutely.
Colin, your opinion, please.
Well, I'll quote Frank's boss that I listened to at the Paris Air Show, and we are at an inflection point, right? So he talked about those inflection points in aerospace from flight through safe flight, through democratized flight, and the fourth one being sustainable flight. So our future will be very different if we do not address this topic. So the demand for actual flying, we have to answer this for the future flyers, which we are on a path to answer.
And the typical answer is technology.
Exactly, and to that point, we're in a bubble here. Where is a balloon? You're going to push it in certain angles. Of course, we're going to have a per unit fuel price increase. We're all seeing that, but it's incumbent on us who build airplanes and build systems to create offsetting value. So I'll give you an example in our propulsion environment. So you may have seen we've got this little project going on in Canada on a Dash 8 with our sister company Pratt. So we've married a 1 megawatt motor to a Pratt engine. And our forecast for that, if we get into and this is a regional airplane, but if you get into a 50-50 environment, we should be able to take the bill down by about 30% by adding the hybridization to it. So fuel price can float a bit, but we injected the technology to keep the balloon the same. And so we're investing $3 billion this year, not abnormal in terms of size, but when you study it, about 75% of that $3 billion is directly linked to this topic. So it's really incumbent on all of us to find that value spot, add that value so that the balloon stays the same. It's just different areas within it.
So we have to learn at least these different angles we have to tackle. In sake of time, and I'm aware that we are here between these people and these hungry people, and so we have only 6 minutes left. So maybe a bit quick answer. And I'm turning now into Tinkerbell, and I'm now whatever the Wizard of the Oz, and you have one wish, so the typical end of a session question. Maybe Frank, what is the individual, the single wish you have for your daily life, which would bring you much closer to zero emission?
The single wish is pretty hard. I think the most important thing for us is to stay focused, to drive the technology, because I fully agree, technology is the answer to the challenge. And we have a really exciting time ahead of us. If you look at the history of aviation, the time now is super exciting. The amount of different ways we have to actually drive the sustainability. What we need is focus, effectively a united industry, and also driving the narrative that flying is a course of good. And it actually can be a course of good which is sustainable.
So we have to make sure that flying and the demand of mobility is not eroded, right?
Yep.
Olivier, one wish. Two? Maybe two. Come on, we can do it.
One. Model-based system engineering in virtual twin as the core of the collaboration within the ecosystem, not company by company, but as a baseline to run together scenarios. And as a corollary of that, skilling and training of next generation of engineers. We don't invest collectively enough in skilling and training of people for what's coming ahead. So invest in skills, and talents.
Yeah.
A few years back, we had a wish. The wish was, now that we have the LEAP, which is 15 to 20% better in performance than the CFM56, my wish was, what about the next step? People were telling me we reached the asymptosis, so we'll never be able to improve. So we had this big workshop at CFM level, Safranji, back in 2017, 18. And that's what our wish. What can we do for this step change? And I told you about it. This is this open fan concept. A lot of challenges along the road. It's not an easy thing to master, but we can see that we can make it. So that part is no longer a wish for me. The wish I have is that there is enough sustainable fuel so that our engine that burns 20% less will burn 20% less and therefore emit 20% less CO2, that we can really make it work with SAF. Because we're doing our part at CFM with the technology, along with our friends at Airbus. We're really collaborating very well. But for the wish to come true of net zero carbon in 2050, we need, in addition to that, we need SAF in sufficient quantity. And that's my wish, is that the whole industry, the governments, whoever, the stakeholders, finally come to terms to the fact that we've got to do it. Because if we do, the combination of technology and SAF, for me, net zero carbon 2050 is not a wish, it's a reality. That's how I see it.
So, ladies and gentlemen, we have enough SAF now.
Good. Then I'm happy.
Pierre.
Wish. I think on the technology side, be it for the infrastructure, be it for the production, there is no technology which we will not overcome. We will be ready. So everybody has been quoting the boss of Frank, so I will do the same. I was reading the interview of President Faure in Washington. He said very simply, technology of hydrogen airplane will be ready by 2035. So all across the chain, my conclusion is that technology is not going to be the roadblock. So my wish is to have on one hand the regulatory framework which progress at the right speed to enable us to make things happen. And on the other hand, a little bit same as Gaël, but said differently, I don't think that the governments will play a big role in the production of SAF. I think what will play a big role in our industry is visibility. Our industry works with visibility. So I wish to have the right visibility from the aviation industry so that we make the right investment at the right time in the right place. So this would be my wish.
Thank you.
He stole my regulatory one. But if I had one wish, it's very hard to answer. But I would say let's not forget the art of multitasking. Because I hear people talk, okay, obviously, Richard Branson's flown his airplane from Heathrow to JFK, and even my wife said, oh, but we can do this, right? That airplane can take 100% SAF. Well, all right, there's some work to do, some regular. But what we shouldn't forget is the incremental steps we can take on the journey. Because I hear people say, well, if you focus on LCAF, it's low carbon aviation fuels, which is probably got about 5% of lift if we get that right, that will distract from the SAF journey. Well, will it? Can't we multitask that? Our flight, we've got this flight profile optimizer offering that comes out of the flight. So Flight Aware, they track in airplanes. So we have this product that digitally communicating to airplanes, working on flight efficiencies. We think we can take 12,000 gallons of fuel out of every airplane every year. So a small step in the journey, but we should be able to multitask and not be distracted by the small things while we continue to focus on the big rocks. So my wish would be, let's not forget how to multitask.
Great, so we have 6, 5, 4 seconds left. So we are in time. Thank you very much for this great answers. And I have to admit, I was skeptic about the targets. Now leaving this panel, I'm much more confident because I recognize leadership in this industry, which is really targeting net zero. It's not only a bubble, it's not only a greenwash subject. The industry and you guys sitting here, also you in the room, you are targeting this with technology and you're tackling technology towards this topic. So I'm very confident that we are closer to this target than we think. Thank you very much.